Now that we've discussed parallel streams and completable futures, I'm going to walk through a more complex example that illustrates how both these Java framework capabilities are applied. This example is called the ImageStreamGang app, and we'll start by describing the structure and functionality of the app. This app is interesting because it applies the Java parallel streams and Java completable futures concurrency and parallelism frameworks. You can download the app at the URL shown at the bottom of the screen. The focus of this discussion is to illustrate how to effectively integrate object-oriented and functional programming paradigms. We'll also talk about how patterns are used to emphasize key roles and responsibilities in the app's overall design. Let's start by describing the pattern-oriented ImageStreamGang app. The user interface for this app is implemented with Java 8 features. It allows you to be able to use streams and completable futures to download, filter, store, and display images that are retrieved from a remote website or websites based on the URLs that are provided. There's a way of being able to communicate with sockets under the hood, which is not really exposed up to the application. It's pushed down into a library deep down in the bowels of the app. The user is prompted for a list of URLs to download. You can provide that list through a menu that's interacted through the user interface screen. The images are then downloaded using one or more threads out of a pool, which of course under the hood is using the Java fork join framework. There's a set of image filters or transforms to apply, and these images that are downloaded are then filtered and going to be displayed and stored in persistent storage on the device. And the app uses a range of interesting Java 8 features. For example, it uses sequential and parallel streams. We'll talk first about parallel streams. It also uses some interesting completable future features, which we'll cover in just a few other lessons. Naturally, we use a variety of different foundational Java 8 features that we talked about earlier, things like lambda expressions and method references, which are much cleaner and less verbose than having to write all that code using anonymous inner classes. Gang of 4 and POSA patterns are applied throughout the ImageStreamGang to enhance its framework-based architecture. Some of the patterns are very essential to its design. These include things like the pipes and filters pattern and the future pattern. Pipes and filters is really at the heart of what Java 8 streams do. They take data and they run it through various filters, which we call aggregate operations. And between those, it kind of gets piped through the flow of data from one aggregate operation or one filter to the next. The word filter here doesn't mean Java 8 streams filter. It means aggregate operations. So pipes and filters is a classic pattern that's used in many other environments, such as Unix pipelines or System 5 streams and other environments that transform data as it flows through various tasks. Future, as we've discussed in the context of completable future, is essentially a proxy that's a stand-in for the result of a computation that runs asynchronously. And you can learn about pipes and filters and futures by taking a look at the links at the bottom of these slides. There's also support for a pooling pattern, which is described in the POSA 3 book. And pooling basically has a pool of resources, which in this case, of course, would be threads that are running in the fork join pool. And that's used to more effectively map the computations onto the underlying processing cores. There's also a pattern called the template method pattern, which is a gang of 4 pattern that's used to describe the various steps in an algorithm and then allow each of these steps to be customized and overridden via subclasses. So you can change the various behaviors of the algorithm without changing its overall structure. A couple other patterns that are applied are decorator and factory method. Factory method is a pattern that's basically a variant of template method that's specialized for creating objects. So you have a method that makes something, and then you can subclass and you can customize how that something is created, what's called a product. A decorator is another interesting pattern that basically allows you to wrap a particular computation with decorators that get applied either before or after the base computation in order to refine or augment the behavior provided by the base computation. There's also a number of other patterns, such as singleton and command, that are used in the ImageStreamGang app. As you may recall from earlier classes, singleton is a pattern that allows you to get rid of global variables while still providing global access to an object that's created on demand the first time that it's accessed. A command is a pattern that's used to be able to take a bunch of functionality and bundle it together in the form of an object. So you can basically have objects that carry out certain functionality, certain commands, and you can put those objects into collections. You can undo the commands, you can redo the commands, you can store the commands, you can have the commands run in different threads, and so on and so forth. So these are some of the patterns that are used throughout the implementation. We'll see that as we go through this. The app itself is complicated and contains many classes. As you can see, there's more than a dozen core classes that we show here on this diagram. Therefore, we'll analyze the design from a couple of different points of view. We'll talk about its pattern-oriented design. We'll talk about the data flows, visualizing the way in which streams and completable futures work. And we'll also, of course, do detailed code walkthroughs to see how it's actually implemented. There's also a video you can take a look at as part of my live lessons tutorials that walks through this example in more detail and also shows examples of it running in the context of Android Studio. These are the pictures that we'll look at shortly that visualize the data flow, just kind of showing how different layers in the stream pipeline can be used to transform the data that flows through it and the computations that are provided at each stage in that pipeline. Of course, the best thing to do is to take a look at the code, and you can download the code here and read it to find how it works. So let's take a look at the app itself. Here's a UML diagram that illustrates the object-oriented design of the app. And this design really demonstrates the synergy between an object-oriented way of doing things and a functional programming way of doing things. These are all the classes that we're going to be focusing on as we talk about the implementation. Some will be focused on more than others. We're obviously going to focus primarily on the ones related to various concurrency models, either parallel streams or completable futures for running the image processing in parallel. If you want to read about more or want to learn about more of the other parts, take a look at my live lessons course I just mentioned. At the heart of this app is a framework, and the framework is used to initiate streams that process input from a list of elements. If you may recall from other classes or other discussions, a framework is essentially an integrated set of components that collaborate to provide a reusable architecture for a family of related applications. And we see frameworks throughout Java 8, things like parallel streams as a framework, completable futures as a framework. Of course, Android has frameworks for handling user interface events. And frameworks are characterized by three main things: inversion of control, in other words, by callbacks, basically domain-centric structure and functionality, so maybe the domain of user interfaces or the domain of concurrent and parallel processing. And they also basically have this concept called the Hollywood principle. That's basically inversion of control. Don't call us, we'll call you back. And you can also essentially take a framework and customize it so it's specialized for particular use cases. In this case, we specialize the StreamGang framework to download and process images via an ImageStreamGang base class. And this is then the base class that's used for the rest of the concurrency models. Sequential, which is kind of the null version or the baseline version that just does it all in a sequential processing model. We have parallel streams approach. We have a couple of different completable futures approaches. The sequential approach just uses a Java 8 stream or Java 8 streams to download and filter the images sequentially. Parallel streams uses a parallel stream to do the same thing concurrently using the parallel streams mechanism. And then we have a couple of different completable futures approaches, and I'll show you one of them in detail later. There's also a class called an image, which is used to store metadata and provides methods for image and file-related tasks, storing the bytes, storing the results of a transformed image on the file system. And we have a whole class hierarchy that applies various patterns like template method and decorator in order to be able to filter and store the images. I won't talk a lot about this here. You can watch the other video if you want to learn more about this hierarchy. There's also a set of user interface classes for the Android version of the app, and then there's also a console version. And interestingly enough, the console version of the app and the Android version of the app share most of the code. Most of the code is shared in common. All the other stuff that we just talked about, so the concurrency, the filtering, the images, that's all shared. And only the user interface portions actually vary. If you go ahead and run the app, and I won't run it right now, but you can run it yourself and see what it does, you see some interesting things. In particular, you see why people might go to the trouble of trying to use completable futures. This illustrates the run of the app downloading, I think it's maybe 10 or so images, maybe more than that. It's a bunch of images. And it demonstrates the sequential version, which is always much slower than all the other versions, versus the parallel streams version, which is always faster than the sequential streams version. And then you see the two completable future versions are always the fastest. And in particular, completable futures 2 is particularly fast. And in one run of the program, the first run you see up here, that was using very large images. And the second run, we're using smaller images. And you can see for the large images that the completable futures version is almost 3 times faster. For the second version, the smaller images, it's almost 4 times faster to use completable futures. And they're also faster than the parallel streams. Your solutions won't always give exactly those kind of results, but it demonstrates why it's worthwhile trying to use the completable futures framework, because it does often give you a speed up. And that's essentially the end of the first part that just gives you an overview of the ImageStreamGang app.